All right, so this lesson is all about percent of change. Just to give you an introduction, the real life application of this. Um, Percent of change you use a lot in real life. For instance, you might say you have 30% more of something, or going to the pizzeria. I would like to get a pizza that is 50% larger. You could be talking about your grades. I want to increase my grades 12 and a half percentage points. Okay, percent of increase, percent of decrease. Are simplified by using the formula. Now you can look at the formulas I have here. I just want to kind of spin something off of this to make sure. So see the one I just outlined there, percent increase, your new amount minus your original amount, all divided by original. Well, that's for the increase part. Notice the decrease is down here. Notice the only thing different is they switch the order of the original and the new amount right here. That's the only difference. Well, I like to do a different formula so you don't have to actually memorize two. My formula to do for percent of change is percent of change is equal to change, so change regardless, and divided by the original amount. Okay. The reason I do that way is because I can talk about what the change is going to be and whether the change is a positive change or a negative change is based on your final answer. For instance, if you're going down on something, well, that's going to be a decrease. So your answer, could be a negative direction. So your answer is going to be in the direction in which you're moving. So let's look at some examples, kind of what that looks like, and go from there. So the first example could be something like here. The table shows the number of hours you spent online last week. What is the percent of change in your original time frame from Saturday to Sunday? Well, looking at Saturday, our original amount is 2 hours. Going from Saturday to Sunday, I noticed that it's a 2.5 hour change. Okay, so the change, my original amount is 2, and I'm going up to 4.5. Okay, well, the change is going to be 2 to 4.5. Now, I did the difference here, but understanding, you can technically put an absolute value here and understand that change is going to be the movement. Well, if we're going from Saturday to Sunday, that's going to be increasing. Okay, that's an increase in the problem. So what is the difference between 2 and 4.5? The answer in my problem is negative 2.5. Well, I could also take this and go in the other direction to solve the problem, and I've done 4.5 minus 2, okay, and still got 2.5 either way. Well, we just know that we're going from Saturday to Sunday. The increase is going to be a total of 2.5. Well, what was the original amount? Well, the original amount was 2 hours online. So the original is the denominator. Original here is 2 hours. Well, what was the increase or decrease? What was the percent increase? Well, we know the time was 2.5 hours. Let's do this as a percent. Well, this is a fraction. 2.5 divided by 2. Well, we talked about converting fractions to decimals and fractions to percents. Well, a percent is out of 100. Couldn't I just do 2 times 50 and get 100 and multiply this one by 50 also and get the answer? Yeah, that would work. Okay, that would end up giving you what? 2 times 50 is 100. 50 times 3 is 150, so 125. So that would be a 125% increase. If you didn't want to go that route, maybe you took your fraction and noticed it was just a division problem. Okay, 2 is outside the house, 2.5. 2 into 2 is 1. Remainder 0, 5. 2 into 5 is going to be 2 times. That's 4. Remainder is 1. Bring down to 0. 2 into 10 is 5. 1.25 is your decimal, which is 125%. Okay, so you can use the formulas they gave you, the increase and decrease, if you want to memorize too. I like to understand that change divided by original is the change of the percent increase and percent decrease, percent change formulas. All right, next one, right here. So the bar graph shows the softball player's home run totals. What was the percent of change from 2012 to 2013? Well, in 2012, okay, she had a total of 28 home runs, and 2013 is 20. Well, if you go from 28 to 20, that's a decrease. Well, how much is that decrease? Well, the change going from 28 and 20, that's a total of 8. So we can say it's a decrease, which we can say -8 for the change, going down 8, all divided by the original. Well, what's the original? What was your first one you compared? The 28. So -8 out of 28 is going to be your fraction. Okay, again, change over original. Now, let's convert this to a percent. Well, 8 over 28, let's do a little division problem. 8 divided by 28. We know the answer is going to be a negative, which is going to say it's going to be decreasing. 28, 8, add your decimal point, go from there. 20 into 8, 0 times. 20 into 80, give it 2, which is 56. Remainder is 24. 28 into 240, I think that's, let's get some check. 28 times 8, that's 64, 16, 20, 24. Okay. So that was 8. And then remainder is 16 on this one. 28 into 160, check 5. It's 40. 140, there we go. We're, yeah, 140 there, 80, 40, 140 there. So I got another one, so that's 5 there. So right now we can keep going, 140, and keep going, but we end up getting a total of 28.5, and keep going on percent. So we have a decrease of 28.5% on that one. All right. Just to get an idea of what the book was kind of talking about, doing the exact same thing. They use a different formula, still have a difference of 8 there. Notice they did approximate, they stopped at that point and went from there. Last but not least, the last one, number 3. You estimate that the length of your classroom is 16 feet. The actual length is 21 feet. Find the percent error. Well, we're talking about error. Percent error is kind of similar to percent change. Only real difference, percent error is we actually have the actual. I know it's the same as like original. Okay. So and then we have the amount of error up here in the numerator. So what was the amount of error? Well, we know that we had the actual be 21, so that's there. So what was it that we guessed? We got 16. Well, if you do a difference of 21 and 16, that's going to give you 5. Now, think you're guessing before you measure, right? You try to estimate that. So our error is we were on the high side or the low side? Low side. So you can possibly say that your error was negative. Just gotta be clear when you describe it, whether it's a you were 5%, 10% below something, or 5% above something. You just gotta be very specific when you do it. The signs can all mean different things, but you have to explain it. So we have 5 divided by 21 as our percent error. Let's change it to a percent now. 5 divided by 21. Let's set it up. I've done lots of division lately. 21 into 5 is 0. 21 into 50 is going to give me 2, 42, 8, 0. Let's go 3. It's 63. It's 17. 21 into 170. Let's go with 8. 21 8 is 168. And 2 and 0. And it gets to 0. So we'll stop there. You can keep going on, but we need to get to a decimal, which is now percent, by doing the but rule. So we get 23.8%. So I was short of the actual by 23.8% short there. And I'll show you what the kind of book does, just so you can see their perspective. Same idea. You get 23.8% again. All right. Here are some problems for you to try. Just see if you can get them. If you don't, then obviously you can practice a little more. So here are yours. Go ahead and freeze it to try them. And then here are the answers. Oh, there's one more. Sorry, I forgot about that last one. Here's the answers now.